to record today's class, today's recording. You're fine, Kaylin. Just miss Monday. One day will not do much to your grade. It's okay. Okay, so let's start today's lecture. We're gonna learn distributive property, okay? Distributive property. Firstly, I'm going to explain what is the distributive property and when do we use it and how do we use it. The formula for distributive property is A times parentheses. In the parentheses, we have a B plus C. This expression has a multiplication. Multiplication of a number A with a group of terms. Parentheses here is the grouping symbol. So in a group, we have two members, B and C. There are two terms. Yeah, you should be able to see that after Monday. Yeah, B is the first term, C is the second term. And they are the two members in a group. And the number in front of the parentheses, yeah, multiplied with the group, is called a coefficient. We see this word again, right? Yeah, coefficient is a very important concept in algebra. And how do we simplify this expression? Or how do we remove the grouping symbol, remove the parentheses? Distributive property is used to remove the parentheses, okay? When you have an expression like that, and you need to remove the grouping symbol, you apply the distributive property. And how do we remove it? How do we remove the parentheses without changing the expression? Yeah, only change the looks, transformation, but will not change what the expression actually represents. When we use the distributive property to get that done, okay? How do we get that done? We are going to distribute the coefficient to each member in a group, okay? We are going to distribute the coefficient to each member in a group. Distributive property, the key word is distribute, right? It's like you have something you want to give each single person, let's say an apple, right? You have a group of friends, you want to give each person an apple. Yeah, you can do that. So here we are going to give each member in a group the coefficient. Remember, the coefficient is always multiplied with whatever the term is. So we give B, the member B, a coefficient A. So A times B. And then we give the member C a coefficient, and then we have A times C. And then we add it together. Yeah, we keep the two terms. Yeah. We have the two terms in the grouping symbol. After we distribute the coefficient to both of the two terms, we will still end up with two terms as the result, but we don't have a parenthesis anymore. So that is how does the distributive property work. When we apply distributive property, we distribute the coefficient of the group to each member in the group. Those members are terms in a group. Does that sound right? Yeah, you can maybe see the coefficient as, let's say, benefit. Yeah, the benefit is applied to the group on the left side. Now the group is dismissed, so the benefit is gonna fall to each member. Yeah, go with B, so you have A times B, and then go with C, you will have A times C, and then you still have the two terms, so you have AB plus AC. The addition sign is used to connect terms in an expression. Okay, the best way to really understand this property is to use it. Let's practice it. Number one, let's read the question. Apply the distributive property and simplify the expression. Number one, the expression is 3 times x plus 2y. You have a parenthesis here, right? Yeah, you have a grouping symbol here in the expression. In the grouping symbol, in the parentheses, how many terms do you see? Yeah, if you were here on Monday, you should be able to quickly identify how many terms in a group. How many terms in a group? Two terms, right? Yeah, exactly, two terms. Yeah, two terms. Awesome. Yeah. The first term is x. The second term is 2y, right? Okay. Remember, if in a group we have two terms, before you apply the distributive property, then after you apply the distributive property to remove the parentheses, we should still have two terms. The number of terms will remain the same. Yeah, before and after applying the distributive property, the number of terms should remain the same. Okay, so the coefficient here is 3, right? The benefit here is 3. So we are going to apply the distributive property. Yeah, distribute the 3 to each member. We multiply the first term by 3. And then we multiply the second term by 3. Remember, we should still have two terms. Yeah, the two terms added together in the result. And then we simplify. 3 times x is 3x. 3 times 2y is 6y. And that's it. It's pretty, straightforward, the first question, because this expression simply means triple the group. When you triple the group, actually it means triple each member. Yeah, triple the group. The group consists of two terms, so it's equivalent to triple each member. So when you triple x, you have 3x. When you triple 2y, you have 6y. That's the reason the result is 3x plus 6y. Do you see that? Guys, do you see that? Yeah, 3x plus 6y. Thank you, Killen. Awesome. Very good. Perfect. That's the first question. Number 2. Let's see the result. Okay, thank you, Jamie. Yeah, number 2, we have a negative half multiplied parentheses. In the parentheses, we have 2x minus 18y plus 19. Yeah, we have a parentheses. Yeah, the question requires us to apply distributive property to remove the parentheses and then simplify the expression. Question, in the parentheses, how many terms do you have? How many terms do you have? Y, what is y? Ricky, what is that mean? Firstly, I want to know, Ricky, what is y means? Oh, yes. Okay. All right. So my question was, in the parentheses, how many terms do we have? Yeah, I saw 2, I saw 3, I saw 4. Well, this is not a difficult question, by the way. How many terms do you see? you have three terms, guys, okay? All right? Yeah, 2x is the first term. Remember that term is this type. Okay, remember we only need to care about two types of terms. Yeah, the first type is a number times a variable. The second type is a constant, right? Yeah, remember constant is a term. So 2 times x, that's the first term. Negative 18 times y, that's the second term. 19 is the third term. And 19 is a constant term. Yeah, 3. Yeah, you see it now. Perfect. Yeah, very good. Yeah, we have three terms. Yeah, we have three terms. Remember, after we apply the distributive property, we should still have three terms. Okay, right after we apply the distributive property, we should still have three terms. Okay, now we're gonna remove the parentheses by apply the distributive property. We are going to distribute the what? Distribute the coefficient. Okay, yeah, we are going to give each of the three terms a coefficient -half. Yeah, simply multiply each of the three terms by -half. Yeah, do not rush. This is what I would do. Yeah, I write each single step down. Yeah, the first term multiplied by -half, and second term multiplied by -half. Yeah, be aware the second term is a negative 18y. The negative sign is with the term. The negative sign is with the term. And then the third term we multiply by -half. Like that, right? You see that? Every single term every term in the parentheses has a factor, -half. Yeah. And the result, the expression still have three terms. Now let's simplify. -1/2 times 2x. 2x is 2/1 times x, right? And that is, you see 1/2 times 2/1, they cancel each other. So we have a -x here. So the first term is -x. And second term, -half times -18y, we have a positive. Negative times negative is half, positive. So this is 1/2 times 18/1. Half of 18 is 9, right? So we have a 9y here. And the last term is going to be negative. Half of 19 is just 19/2. And that is simplified enough. The resulting expression has all the three terms. Okay? Yeah, if you don't see that, we can also do this way. The first term is 2x. You multiply the first term by -half. Positive times negative gives you negative. And half of 2x is just x. When you multiply by half, means you're gonna have what you have, right? Yeah. So half of 2x is just x. You determine the sign first. And the second term is -18y. You multiply that by -half. You determine the sign first. Negative times negative is positive. So we have 18y times half. Times half again means you get a half of 18y. Half of 18y is just 9y. Right? And then 19 times -half. Positive times negative is negative. Negative 19 times half, that is a -19/2. So, and then you're going to add the three terms together, you have the result. Okay? Yeah, you can break them down on your scratch paper. Here is the breakdown. Let me know if that's understandable. Yeah, this question is a little bit more challenging than the first one because the coefficient is a fraction. But think about the fraction is just a half. When you multiply a quantity by half, you just get a half of the original quantity, right? Yeah, you just get a half of the original quantity. Very good. Yeah, feel free, let me know if anything is not clear. Especially remote class, I do not see you. I do not see your facial expression, you know. Yeah, I would like you be more open for the communication. If you have no question about number 2, let's move to number 3. Yeah, let's see any little confusing. Which part confuses you, Jamie? When
Well, I'm
we
ready. Go ahead.
So apply distribute when do we apply distributive property? We apply distributive property when we need to remove the parentheses. Yeah, the
Right.
purpose is to dismiss the group, but without changing the expression. So original expression in the parentheses in the group, we have 3 terms, and the negative half as coefficient is applied to the group. So once we dismiss the group, the coefficient gonna go with each member, right? Go
Right.
with each member. Yeah. So on your scratch paper, you
Mm-hmm.
can do this. Yeah. You give the first term coefficient negative half. So you multiply, the first term is 2x. You multiply 2x by negative half. You got a negative x. Do you have a question about this step?
No, I'm writing everything down, so I'll just have to keep looking at it. It'll click.
Yeah. So the second term in the group is negative 18y. We give that term coefficient negative half. We resolve 9y. And the third term is 19. We give 19 coefficient negative half. The result is negative 19 over 2. And then we just need to put those 3 terms together, and that's the result.
Okay.
1 times would still be correct. 1 times. Y is 2 times negative half, not a 1x. Did I do anything wrong here? Yeah, it is 1x. But it's negative though. Negative times positive is negative. You just don't have to write the 1. Yeah, you don't have to write a 1. It was confused by the negative times negative being a plus. Yeah, negative number times negative number give you a positive number. And a negative times positive is negative. That's the rule.
So I'm actually curious, if we would have simplified the 19 over 2 and just put 9.5, would that be incorrect or would that still be correct?
It's correct. Decimal
Okay.
is a form. Actually, I can do it again in a more organized way. Let me do it again. So in a group, we have 3 terms. We agree on that. So after we apply distributive property, we expect to have 3 terms again, right? Yeah, but they will look different because each of the terms gonna have a coefficient negative half. So the first term is 2x, second term is negative 18y, third term is 19. We agree on that. I believe there's no problem with that, right? And we are going to give or distribute the coefficient to each single of them. We are going to distribute the coefficient to each single of them. Okay? Yeah, remember coefficients always multiply. So we are going to multiply each of the 3 terms by negative half. Multiply by negative half. Multiply by negative half. When you multiply 2 numbers or 2 quantities with a sign, determine the sign first. Okay, determine the sign first. Positive times negative. By the way, this is not minus. Okay, this is not 2x minus half. This is 2x times negative half. Again, this is 2x times negative half. Positive times negative is negative. Yeah. And then you copy everything else, 2x times half, right? Yeah, determine the sign first. And then we have 2x times half. When you multiply a quantity by half, you would get a half of the quantity. Isn't that very obvious? Yeah, when you multiply something by half, you will get half of the quantity. What is half of 2x? 1x, right? Yeah, 1x. But you still have the negative sign in front of it. So it's a negative x. Do we have any question about this step? Do we have a question about this step after we distribute coefficient negative half to the first term? Okay, yeah, I think this time is better. Yeah. Now we look at what would we have after we give the second term the coefficient. All right. Again, this is not negative 18y minus half. Okay. It is negative 18y times negative half. Yeah, we are multiplying. So negative times negative is a positive. So the product is a result multiplication. So the product would have a positive, right? But we don't have to write positive. We don't have to write a positive sign. So just ignore the sign. We do not have a sign here. And we just have 18y times half. Again, when you multiply a quantity by half, you get half of the quantity, right? What's half of 18y? What's half of 18 apples? Half of 18 apples is 9 apples. So half of 18y is 9y. Remember, you can see the variable part as chips, right? Yeah, half of 18 chips. Yeah, you have 18 chips. You go to casino, you get 18 chips. You want to give half of them to your friend, and you're gonna give him 9 chips, right? So 9y. Any question about this step? The 9y, not just 9y. Is it still negative or does that cancel out? It cancels out, Jamie. That's a good question. It cancels out. Yeah. Negative times negative is a positive. Okay? Yeah. When we need to apply the rules from foundation 1, I would say let's just memorize it because we don't really have time to complete like thoroughly to explain those rules. Yeah, this one is easier. Makes more sense now. Okay, yeah. Yeah, if it's easier, that means we are making progress. So that's the second step. We distribute the coefficient to the second term in the group. Now we are going to do the same thing to the third term. The third term is just the number 19. Okay, yeah. 19, again, this is not 19 minus half, okay? This is 19 times negative half. And a positive times a negative is negative. So put a negative sign here to remind you. And then you consider what is 19 times half. Yeah, earlier I heard, can I use decimal? Totally. Half of 19 is 9.5. Yeah, you can just write 9.5. That's totally fine. Yeah. Half of $19, right? Half of $20 is $10. Half of $19 is 9.5. So you have negative 9.5. Or if you want, just leave 19 over 2. It doesn't matter. Both of them are correct. Any question about this step? Yeah. So simply you multiply each single term. Yeah, simply multiply each single term by the coefficient. The coefficient was multiplied with the whole group, but now you remove the parentheses, you dismiss the group, then the coefficient go with each term. We talk about term on Monday. All right, so after we give each term the coefficient, we have this, and this. 3 terms, and we're gonna add them together. That gives us the result. Yeah, that's gonna be the answer of this question. We have negative x plus 9y minus 9.5, and that is your answer. Yeah. So yeah, negative x plus 9y minus, yeah, that's not equal sign. That's not equal sign, right? Minus 9. Yeah, okay, very good. Perfect. Better? Is that better? Okay, before we move to the next question, I want to talk about the notation for multiplying two numbers or two quantities in algebra. Okay, I'm going to take 2 and 3 as the example. This means 2 times 3, right? Yeah, the cross is the multiplication symbol. Yeah, of course, that means 2 times 3. Sometimes we use a dot in between the two numbers. That also means 2 times 3. Yeah, we know it's 6, but I'm just showing the notation. But sometimes we don't even use the notation this or notation this. We use parentheses. Yeah, this is also means 2 times 3. Or we use parentheses to frame 2, and this is also means 2 times 3. Do you see that? That's the reason when we see negative 18y times negative half, that is definitely not negative 18y minus half. It is negative 18y times half. Well, sometimes we even put this here. Yeah. So 2 times 3 can also be written as this. That also means 2 times 3. Okay? Yeah, you should have those details in your note. All those notations means 2 times 3. Yeah. So now when you look at 19 parentheses, in the parentheses you have negative half. That's not 19 minus half. That is 19 times negative half. Better? Yeah, this is important, okay, guys? Yeah. We have multiple ways to express multiplication. Most of the times, we don't even use the notation, the multiplication symbol with this dot. Yeah, we use a parentheses. We use a parentheses. Are we good with that? Okay, very good. Thank you for your response. Now let's move to the next question. Yeah, let me erase that, and then we move to question number 3. This strategy in number 2, like on your scratch paper, deal with each term. Deal with each term on your scratch paper. Yeah, when the term looks a little more complicated, yeah, you can try that strategy and then put them back. In number 3, we have 10x minus 5 times parentheses. In the parentheses, we have x minus 2y. Okay, this expression has a parentheses. Yeah, we need to apply the distributive property to remove the parentheses. Then we can look at the expression to see if we could further simplify the expression. So here, I'm going to ask a question. So we see the parentheses. Can you tell me what's the coefficient of the parentheses? What's the thing we need to distribute when we apply the distributive property? Yeah, can you tell me that? Yeah, is it 5 or negative 5? Yeah, is it gonna be 5 or negative 5? Yeah, is it negative 5, okay? Yeah, see the coefficient as negative 5. Yeah, please see that the coefficient is negative 5. The expression here actually is 10x plus what? Plus negative 5 times a group of two terms. So the coefficient is negative 5, not positive 5. Yeah, please see the coefficient of the parentheses is negative 5. The thing we are going to distribute to each member in a group is negative 5. Okay, very important. So let me write it down. Yeah, where the apple we are going to give to your friends, right? Each member is negative 5. All right, so let's do that. So if you think the 10x is bothering you, it's okay. You're gonna draw a scratch paper. You're gonna work on the distributive property on your scratch paper. Okay, we can work on this part in the scratch paper. Negative 5 times parentheses x minus 2y. Yeah, what do we need to distribute? We need to distribute negative 5. All right. Yeah. So we have two terms in a group. Yeah, you should see that now. We have two terms in a group. We have two terms. Give me a time. Let me get more space here. Make the scratch paper bigger. In the group, we have two terms. First term is x. Second term is negative 2y. At this point, you should see the negative sign goes with the term. Okay? Yeah, in the parentheses, we have two terms. The first term is x. The second term is negative 2y. Do you see that? Yeah, do not worry about is minus 2y, x minus 2y. Do not worry about minus, okay? It's all about addition. The negative sign is with the second term. Okay, very good. What was the answer on last? Ricky, what was the answer on number 2? Is that your question? It's negative x plus 9y minus 9.5. Yeah, correct. Yeah, thank you, Amanda. Okay. Guys, do you see that? Yeah, I asked the question already. Yeah, in the parentheses, we have two terms. The first term is x. Second term is negative 2y. We covered that on Monday. Yeah. So now we are going to distribute negative 5 to each member, right? Okay. So we are going to multiply each member in the parentheses by negative 5. We're going to multiply the first term by negative 5, multiply the second term by negative 5 as well. Yeah. So the first term is x. We multiply by negative 5. And second term is negative 2y. We multiply negative 5. Okay, let's see what we have. The first term, x, multiply by negative 5. Positive times negative, negative. And we have 5 times x. We don't really write x times 5. Yeah, we don't really write x 5. Because remember, the first type of term look like a number times variable. Yeah, we write the number in front of the variable. So the result of x times negative 5 is just the negative 5 times x, negative 5x, okay? Negative 5x. And the second term here, negative 2y times negative 5. Negative times a negative is a positive, but we don't really have to write a positive sign. You can just ignore it, right? And you know you're gonna have a positive, yeah. And 2y times 5 is 10y. 5 times your 2y, you have 10y, okay? Yeah, exactly. Yeah, thank you, Felina. Yeah. So now you have two terms. After you distribute the two members in the group, now look like that. And you're gonna add them together. After you distribute, you should have -5x plus 10y. All right? Yeah, that's this part. That's this part. And you can put it back. You put it back. Remember, we still have 10x in front. Yeah, bring it down. It's still there. It doesn't disappear. Yeah, 10x, and then you put this back. Put this back. Okay, you put that back. It is -5x plus 10y. So far, so good. What happened? On the scratch paper, we apply the distributive property, and then now we put it back. We put it back into the original expression. Yeah. All right. How many terms now in the expression? How many terms now in the expression? 3. Awesome. Any of them are like terms? Did we learn like terms on Monday? Yeah, let's recall. Yeah, what are like terms? Yeah, thank you, Jill. 2 of them are like terms, right? Yeah, like terms are terms with exactly the same variable part. Yeah, look at here. You have 10 apples, and you have 95 apples here. So those 2 terms are like terms. And this is not like term. This one is bananas, right? You cannot combine them. Yeah. Okay, so we see 10x and 95x, they are like terms. We are able to combine them. Same letter or variable. Exactly. Thank you, Jill. Yeah, 10x minus 5x. Perfect. And we can combine them. How do we combine them? What's the result after we combine them? 10x minus 5x? 5x, right? And then bring down the 10y. I can explain why 10x minus 5x is 5x here. Yeah, 10x simply means you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. 10 times x, you have 10 x's. And then you minus 5x, you get rid of 5 of them. 1, 2, 3, 4, 5. You get rid of 5 of them. And you have how many left? 1, 2, 3, 4, 5. 5x left. Okay, that's exactly what happened when we combine like terms. You take away 5x from 10 x's. Yeah, plural, 10 x's. Yeah, how about this? See x as apples. You take away 5 apples from the 10 apples. Of course, you have 5 apples, right? Yeah, so the result is 5x. We went over this on Monday. So that's why after we combine like terms, we have 5x. And then we cannot combine with 10y because they are not like terms. So the result is 5x plus 10y. That is your answer. Yeah. 5 bananas plus 10 apples. Yeah, you see x as bananas. Exactly. Exactly. Very good. Perfect. Any questions about number 3? Do you feel comfortable about the distributive property now? Do you think you can do that on your own? Much better? Yeah. But it takes practice, right? Yeah. I'm sorry that you might not have the access to your homework yet. But you can practice the same questions on the class worksheet. Yeah, class worksheet. You know, my teaching philosophy is practice the same good question, one good question, 10 times is better than practice 10 different questions. If you have a one good question, you practice enough, you really understand it, you understand it thoroughly, then you would be able to do any other similar problems. Yeah, thank you, Amanda, for agreeing that. Yeah. So you don't have to do many different questions. If you don't understand, it doesn't matter how many questions you practice, you still don't understand. But if you understand even just one question, you can just understand the essence through that one good question, then you should be able to do other similar questions. Of course, based on top of that, you see a variety of questions that would help for sure. Okay, so that is the distributive property. Okay, the distributive property. The second topic we are going to cover is to learn how do we evaluate expressions. Yeah, so number 12 and 13. Yeah, so next we are going to use number 12 and 13 in the class worksheet to talk about how do we evaluate expressions. Okay? Yeah, what is expression? What is an expression? It's a bunch of terms added together. Yeah, so far, okay? So far, what is an expression that you would encounter? Just a bunch of terms added together. That's it. Yeah. Okay, so let's explain number 12. Number 12 is to evaluate this expression, -2x cubed for x equals -5. All right, this is a term actually. All right, yeah, so it is an expression. The numerical part is 92, the verbal part is x cubed, but doesn't matter. Yeah, we do not know the value of this expression because it has a variable. It has a variable x. Yeah, we don't know the value of x, so we don't know the value of the expression. In order to know the value of the expression, we have to know the value of the variable x. Yeah, because the value of the expression depends on the value of x. The question tells us the value is 95. So we are going to find out what's the value of the expression when x assume 95. The purpose I have this problem is to show you how do I plugging in. We use plugging in to evaluate expression. We plug in a lot. Plugging in is a very probably the most common, one of the most common used technique in algebra. Okay, yeah, plugging in. Yeah, what does that mean? We want to know the value of the expression. Then we want to replace variable x with its value -5. Okay, yeah. So we are going to substitute 95 for x. We are going to put 95 in the place of x. Okay, because the value of the expression depends on the value of x. So we know the value of x is 95, so we're gonna plug in. Yeah, let me show you how do I plug in. And I strongly recommend you do the same, especially when you don't like algebra and you didn't have you are not comfortable with algebra. So you should try the method I recommend, and you might start to feel comfortable and confident. So it's very easy. Everybody can do that. Okay. I would, yeah, whenever I plug in, I would use a parenthesis. I use a red parenthesis here to frame the variable that I was going to replace. Yeah. All right. And then I erase the variable. I take it away because we are going to place 95 there. Okay? It's like there's an outlet here on the wall, and my phone is charging. I have my charger there, and you want to use it. How do you use it? You have to unplug mine and then plug yours, right? Yeah, so what happened here is we use the parentheses to frame X, to hold a place for X. And then we unplug X and plug in 95 because they are the same. That is a given. That is given by the problem. Yeah, you might ask, well, why do you put the 95 there? Because it's given. It's given that X equals 95. All right, and then we are going to evaluate this expression by using the correct order of operations. That is something we learned in Algebra 1, I believe. This is Foundation 2. Anybody remember what does PEMDAS mean? What does please excuse my Dion Sally mean? Huh? Yeah, PEMDAS means please. Yeah, please. Let me write it down. Yeah, that's something should be in Foundation 1, I believe. Yeah, should be in Foundation 1. Yeah. Please excuse my dear Aunt Sally. Yeah, that's the sentence you want to remember to remind you PEMDAS. Parentheses. Yeah, E means exponent. That's a good question. Yeah, let me explain those letters. P means parentheses. E means exponent. Okay, M means multiply, D is divide, A is adding, S is subtract. That is one of the 3 rules about the correct order of operations. Okay, yeah, we only use this rule today. Yeah, if we use another 2 rules, I'll let you know. Okay, so that means exponentiation has the priority compared with multiplication. In this expression, we have multiplication. Remember that? We actually have a multiplication here. Yeah, -2 times an exponential expression. Yeah, we actually have a multiplication there. And this part is an exponentiation, right? So should we do the exponentiation first or the multiplication first? Based on the PEMDAS. Should we do the exponentiation first or the multiplication first? Yes, we should do the exponentiation first. Exactly. Because the PEMDAS, E is in front of M, right? Yeah, very good. All right, so let's do the exponentiation first. Yeah, let me draw a scratch paper. Yeah, this is my scratch paper. I'm going to handle the exponentiation here. In this exponentiation or exponential expression, we have 2 parts. Remember, base and exponent. Anybody can tell me what is the base? Is the base 5 or -5? Is the base 5 or -5? -5. Awesome. Very good. Yeah, that means you remember what you learned from Foundation 1. Yeah, so that means we can write this exponential expression as a repeated multiplication. Use the base 3 times. 1, 2, 3. Yeah, don't forget the base is -5, not +5. All right, guys, help me out. Since you have a calculator, right? Yeah, you can use a calculator to figure out what is 95 times 95 times 95. Yeah, I would determine the sign first. Negative times negative is a positive, and positive times negative is negative. So the result, the product, should be negative, right? Yeah, negative times negative is a positive, and then positive times negative is negative, and then 5 times 5 times 5 Do you have negative 125? Yeah, thank you. Awesome, awesome, guys. Very good. So the exponentiation part, let me use a different color. This part is a negative 125. Yeah, let's put it back. So we have 92 times negative 125, right? You see, I never rush, and I only do one step at a time. Okay, now we can handle the multiplication. We have 92 times negative 125. Negative times negative is positive, right? Yeah, you don't have to write a positive sign here, but it doesn't hurt. Write it down, or you can just ignore it. Yeah. What is it? 2 times 125? 250. Yeah, awesome. Anybody has a question about this problem? Do you see how do I plug in? How important the parentheses is? Yeah, use the parentheses. If you trust me, if you do not use the parentheses, very, very likely you'll mess up the sign and the structure. You know, to a physician, a doctor, and a nurse, what is the word? Anatomy? Anatomy. Yeah, anatomy. Learning anatomy is super, super important to be a doctor or nurse, right? Yeah, that anatomy is the human body structure. And if you are an architect, it's very important for you to see the structure of a building, a construction, right? Same thing. When we learn mathematics, it's very, very important for us to see the structure of an expression. And you're going to see the structure is a multiplication, 2 parts. 92 is the first part, and the cube here is the second part. But by PEMDAS, we should do the cube first and then multiply. Any question about this? Let me know. Is there videos over this also? I'm recording. Am I? Yeah, I am. I'm recording it. So you should be able to rewatch the video again. The recording is in Blackboard. Ricky, if you email me, I can send you the link to show you how do you find the recording. Today I sent a link to Caitlin, right? Caitlin, did you find a video? Yeah. Okay. Well, let's look at number 13. Let's look at number 13. It's about evaluate again. I might mess up the order of the number. Get rid of this. Number 13. How about this? Okay, good. Number 13, we are going to evaluate 11x minus 12y for x equals half and y equals negative 1/3. This expression, how many terms? 2 terms, right? Yeah, 2 terms. Yeah, that's the structure that you need to see. Yeah, we have 2 terms in the expression. And it contains 2 variables. So the value of this expression would depend on the value of x and the value of y, and they are given. It is given that x equals half, y equals negative 1/3. Let's plug in, okay? Let's plug in. So same with earlier. I would use a parentheses to frame the variables. Yeah, I use 2 different colors. Do you see that? I use a red color to frame x, add a blue color to frame y, because we have two different variables, right? Yeah, remember the red parentheses is holding the place for x. The blue parentheses is holding the place for y. And now we know what to put in the parentheses. What go inside the red parentheses? What's gonna go inside the red parentheses? Yeah, you can tell me. Yeah, it's actually faster.
1/2.
1/2. What's gonna be inside the blue parentheses?
-1/3.
Perfect. Thank you. Do you see I do anything else in this step? I didn't do anything else. Yeah, so do not rush. Do one step at a time. Yeah, exactly. Thank you, Kellen. Kellen, did you find the recording in Blackboard? I think it's you emailed me, right?
Yes, from Monday's class.
Yeah, did you find a video?
Yes, I did that, and then I did that today before this class.
Awesome, awesome. Yeah, perfect.
Now that
Okay,
I know
so
that class is on Mondays and Wednesdays, I won't have to do that again.
But yeah, it's okay. That happens. So now we have 11. Yeah, so now we're gonna evaluate this expression. In this expression, oh, I have Grammarly on, so weirdly think. Let me quit Grammarly. Okay. So in this expression, we have multiplication, 11 times half. We have another multiplication, 12 times negative 1/3, sorry, negative 1/3. And we have subtraction, yeah. PEMDAS. So multiplication before addition, right? Or multiplication before subtraction. So we need to handle the two multiplication first. 11 times a half, you can do 5.5, right? No problem. Yeah, decimal perfectly fine. Yeah. If it's a finite decimal, it's totally fine. Or 11/2, same thing, right? Yeah. So 5.5. And then the second part, that's the first part. Second part is -12 times -3rd. Negative times negative, positive. Positive 12 times 1/3. What is a third of 12? You have $12. You have three kids, and you give each kid $3. Sorry, $4 to evenly distribute the $12, right? Yeah, it's 4. So it is a +4. Perfect. Yeah, +4. So the answer is 5.5 plus 4. Yeah, you don't have a negative anymore, okay? This minusing sign can be seen as a part of 12, -12, as a factor of the second term. So 5.5 plus 4, you have 9.5. All right. Yeah, this question is also about plugging in, but it has two different variables. Any questions? Any questions? We went over 2 topics so far today. First topic, the distributive property. When do we apply it? We apply it when we need to remove the parentheses, right? How do we apply it? We just distribute the coefficient to each member in the group, each term in the group. And second topic we learn is how do we evaluate. And actually, I have something to elaborate before we go to the next thing. Yeah. What if we have this? What if we have 1 times x minus y? What if the coefficient of x is 1? Yeah, for example, we have 2x plus parentheses x minus y. What if the expression we have is 2x plus parentheses x minus y? Anyone can tell me what's the coefficient of this parentheses? Any?
Just 1.
Yeah, just the 1. Yeah. So when the coefficient of the parentheses is 1, we can just literally remove the parentheses. And that's the only case we can do that. Okay, and that's the only case we can do that. When the coefficient of the parentheses is just 1, we could really just remove it, get rid of it. Just it doesn't exist. And then we combine like terms like that. All right, I hope you can write this down on your note. When the coefficient of the parentheses is 1, we can literally remove the parentheses. And that's the only case we can do that. Yeah, that's the only case we can do that. It's because the coefficient is 1, and 1 is the multiplicative identity. When you distribute the 1 to the members, when you multiply the member by 1, it doesn't do nothing. Okay, yeah, please have that sentence on your note. Let me repeat it again. Say it again. When we apply distributive property, when the coefficient of the parentheses is 1, we can simply just remove the parentheses. But that's the only case you can do so. Other cases, you cannot just remove the parentheses, okay? Yeah, I had a student just, I said remove the parentheses, but by using distributive property, you cannot just literally erase the parentheses, you know what I'm saying? Yeah, you have to properly using the property. And what if the expression is, let's say 4x minus parentheses x plus 2y. Yeah. How about negative x plus 2y? Yeah. So in this expression, we have a parentheses. In order to simplify this expression, we need to remove the parentheses, right? Yeah, because the terms is trapped in a grouping symbol. We have to, like a wall, we have to break those walls to free them, and then we can combine them together. The outside member and the inside member, we can combine them. Yeah. Question. In this expression, what is the coefficient of the parentheses? What is the coefficient of the parentheses? -1. Just -1, not 2. Just -1 here. Okay? Yeah. I hope you see that. The coefficient actually is -1. I want to make sure everybody sees that, right? Do you see that? Yes or no? Okay, awesome. Just the -1. Perfect. Yeah. When you have a number, you multiply the number by -1, you know what you get? You get the opposite. Okay? When you have a number, you multiply the number by -1, you get the opposite of the original number. Yeah, we know what is opposite, right? Yeah, so we distribute the 91. Basically, we take the opposite. So a easier way to do that is you see the -1 coefficient as opposite. Yeah, for example, so let's start from 5. What's the opposite of 5? 95, right? So whenever you place a negative sign in front of a quantity, you get the opposite of the quantity. Let me do it again. What's the opposite of 5? Negative 5, right? Yeah, when you place the negative sign in front of a quantity, you get the opposite. So this basically means the opposite of 5. Yeah, I'd like you to see that. When you place a negative sign in front of a quantity, you get the opposite of the original quantity. Yeah, for example, what's the opposite of negative 5? What's the opposite of negative 5? Opposite of negative 5, what is it? It's just the 5, right? You don't have to struggle negative 1 times negative 5. It is just the opposite of negative 5. Opposite of negative 5 is positive 5. Yeah, opposite of, yeah, exactly. Yeah, I like to see that way. And I hope you do the same. Instead of doing negative 1 times negative 5 and confuse yourself. And the better way to see the structure is to see that as the opposite of negative 5. We know opposite of negative 5 is positive 5, right? So you get that. Okay, so when the coefficient of a group of the parentheses negative 1, it simply means the opposite of the group. All right? Yeah, this part simply means we have opposite of the group. Then now we're going to remove the parentheses. We're going to distribute the group. Then the opposite is going to go with each member. So the opposite of the group is going to be equivalent to the opposite of each member. So let's bring down 4x. It doesn't involve with the distributive property. So the opposite is going to go with each member. We have two members, right? We have two members. The first member is the term negative x. Second member is the term 2y. Okay, what is the opposite of negative x? What is the opposite? We apply opposites. We find the opposite of negative x. What is the opposite of negative x? Positive x. Very good. We have positive x here. And what is the opposite of 2y? Negative 2y, right? Yeah, exactly. You got great. Negative 2y. You see that? So the opposite of the group now gonna be the opposite of opposite of each member. So we have the opposite of first member, opposite of second member, just like that. And then you can combine like terms. Let me know, is that clear? Does this way to look at the structure help you? Yeah, instead of seeing that as -1 coefficient, of course, is also correct if you just multiply -1, right? You see that as the opposite. Yeah, this yellow part is just the opposite of the whole group. Now you dismiss the group, then you're going to have the opposite of each member. The opposite of the first member is x. The opposite of second member is -2y. And that's it. Okay, awesome. Now we have is 26. We have 24 minutes. Yeah, we're going to start the next topic, okay? And that topic helps us with the fractions and helps us with chapter 6. Chapter 6 is the main chapter of this course. Yeah, chapter 6 is factor polynomials. So I want to prepare you from the very beginning of the semester. So let's start it. We start from prime number, okay? Let's write the definition for a prime number. A prime number is a whole number Bigger than 1? Oh, sorry. Let me maximize this. Okay, bigger than 1 and only has 2 different factors. The 2 different factors are 1 and itself. Yeah. Write down the definition of a prime number. Very important. A prime number is a whole number that is bigger than 1 and only has 2 different factors. It involves whole number. Okay, I have a question. Whole numbers. Anybody can tell me what is the smallest whole number? Yeah, what is the whole number set? It's okay, we're gonna take time to really understand. A is not 2. Yeah. What's the smallest whole numbers? Whole numbers include 0, 1, 2, 3, 4, and so on. Yeah. I do need you to know that the smallest whole number is 0. Okay? Yeah, I do need you to know the smallest whole number is 0. Whole number set include 0, 1, 2, 3, and so on and so on and so on. Yeah, very good. Don't forget that. You should have that in your note. Yeah. How do I just? Oh, this does this. Okay, I'll just keep that there. This. No. Here. Go back. Okay. So whole number and a factor. Yeah, we also mentioned factor in this definition. Factor here means a multiplication factor. Let's understand what is a factor and what is a multiple. Yeah, those two concepts always go together as a pair. Factor and a multiple. Yeah, very straightforward. Let's say we have 15 equals 3 times 5. We all know that, right? Yeah. Then we would have 3 is a factor of 15 because 3 goes into 15 completely 5 times. When 3 is a factor of 15, 15 is a multiple of 3 5 times. Similarly, or same thing, 5 is a factor of 15. 5 goes into 15 3 times. When 5 is a factor of 15, 15 is a multiple of 5. 15 is exactly triple of 5. So that's the concept of factor and multiple. Yeah. Similarly, we can also write 15 as 1 times 15, right? So 1 is also a factor of 15. Yeah, 15 is also a factor of 15. So that's the concept of factor and multiple. The definition of prime number involves. Let's go back to definition. In order to be a prime number, the prime number can only have 2 different factors. The 2 different factors is number 1, and itself. If the number has the 3rd factor, then the number is not a prime number. Okay. We were talking about 15 earlier. Anybody would like to use the definition to determine is 15 a prime number or not? Yeah, let me repeat the definition. In order to be a prime number, the number can only have 2 different factors. The 2 different factors are 1 and itself. No, yeah, you're right. Very good. Exactly. 15 has 4 different factors. 15 has 4 different factors. Okay, 1, 3, 5, 15. Okay, besides 1 and itself. In fact, any number has 1 and itself as factors. Yeah, because 1 goes into any whole numbers, and the number itself goes to the number itself 1 time. So any number at least has 1 as a factor and itself as a factor. But 15 not just have 1 and 15 as its factors. It has 2 extra factors, 3 and 5. So based on the definition, it's not a prime. When a number is not prime, it's a composite, but we don't have to worry about that. Yeah, it's just not prime. Okay, now I'm going to write whole numbers from 1 all the way to 20, and you're going to help me to determine which of them are prime, which of them are not. Okay, I'm going to write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's go through each of them. Is 1 a prime number? Is 1 a prime number? 2, 3, 5, 7, 11, 13, 17, 19. That's awesome. Thank you, Dakota. Yeah, very good. Yeah, we need to remember those. Yeah, but let's go over those numbers by using definition and explain why. 11, oh, N, what is that? Ricky, what does that mean? No? Oh, 1 is not. You're right. Why 1 is not? Because 1 only has 1 factor itself. And in order to be a prime number, it needs has 2 different factors, right? 2 different factors. So 1 is not. What about 2? Is 2 a prime number?
Yes.
Yes, because it has 1 as a factor and 2 as a factor. Okay. So here we are going to write down a note. You can use that as a bullet. Yeah. So 2 is the smallest prime number. Okay, if you see a question ask you, what's the smallest prime number? It is 2. It's not a 1, it's not 0, it is 2. Okay, 2 is the smallest prime number. And also 2, yeah, I'm not going to use it's very confusing. I'm gonna use this to stress is important. And also 2 is the only even prime number. 2 is the only even prime number. Yeah. What does that mean? That means that all other even numbers are not prime. For example, 4. 4 is not. 4 is even, right? 6 is even. 8, 10, 12, 14, 16, 18, 20. The conclusion that 2 is the only even prime number means all other even numbers are not prime. Yeah, let's see why. Okay, let's take a 4 as example. 4 has 1 as factor, itself as factor, because it is an even number. It has the third factor 2. Yeah, what is the even number? Even number divisible by 2. So all even numbers have 2 as a factor. So 4 has 3 different factors. That make a 4 composite, not prime. Same with 6. Besides 1 itself, it has the third factor. Of course, 3 is also a factor, but at least it has 3, the third factor too. Yeah, because all other even numbers besides 1 itself has the third factor, which is 2. That make all other even numbers composite, not prime. Am I clear about that, guys?
Yes.
Okay, what about 3? 3 is a prime, right?
Yes.
What about 5?
Yes.
Only 2 different factors. What about 7? Yeah,
Yes.
how do you know? 1 is a factor, 2 is not. If we divide 7 by 2, we have 3.5. It doesn't work, right? Yeah. And 3 doesn't work. 3 goes into 7 twice with remainder 1. 4 doesn't work. 4 goes into 7 one time with remainder 3. 5 goes into 7 one time with remainder 2. 6 goes into 7 one time with remainder 1. So only 1 and 7. You just have to go through all the numbers. What about 9? Is 9 a prime number? No. You're right. Yeah, 3. Yeah, it has 3 as the third factor. Perfect. 9 is not. It has 1, 3, 9. Okay. What about 11? Yeah, you can try. 11 only has 1 and 11. 13 is a prime. Same method you can apply. What about 15? We did a 15, right? 15 has 4 different factors. What about 17? Yeah, same method. You try. 1 is a factor. 2 doesn't work. You divide 17 by 3, you get a decimal. Divide by 4, you get a decimal. 5 the same. And so on, all the way to 17. So you can see that 17 only has 2 different factors, 1 and 17. 19 is the same. Okay? Yeah. Earlier, I think it's Felina. Oh no, Felina has 1. 1 is not a prime number. Dakota has the correct list. Yeah, 2, 3, 5, 7, 11, 13, 17, 19. Yeah, those are the prime numbers from 1 to 20. And I want you please memorize them. Okay? All right. So next up, we are going to learn a very important technique. Actually, we have 10 minutes. With 10 minutes, we are going to finish this. And then we're going to do the technique next time. A few tricks, as I included in the note, I probably messed up the numbers, but a few tricks I want you to know. I'm going to type them, okay? A few tricks. The first one, how do I know if a number divides by 2? If a number is even, then the number is divisible by 2. When the number is divisible by 2, the number has a factor of 2. Also, if the last digit, I need to erase those, and then, excuse me, a little messy, apologize for that. If the last digit of a number is even, then the number has a factor, this is auto type, of 2. Okay, the first tip or first trick is to help you determine how do we know if a number divides by 2, right? If the number is even. Yeah, how do we know the number is even? We look at the last digit of the number. If the last digit of the number is even, then the number is divisible by 2. It has a factor of 2. And if in other words, if the last digit of the number is 0, by the way, 0 is even. Okay? If the last digit of the number is 0 or 2 or 4 or 6 or 8, then that number has a factor of 2. Okay, so the second trick is, or tip, is to help us determine if a number divisible by 3 or not. Yeah. If the sum of all the digits of a number is divisible by 3, then the number is divisible by 3. Yeah, if the number is divisible by 3, then it has 3 as a factor, okay? It's divisible by 3, means it has 3 as a factor. Yeah, for example, let me give you a very, let me give a small number first, 18. How many digits in 18? 2, right? Yeah, we added the 2 digits together, what do you have? 9, yeah. Is 9 divisible by 3? We know 9 is divisible by 3, right? Yeah. So since the sum is divisible by 3, we know 18 is divisible by 3. Okay, 3 is a factor of 18. 3 goes into 18 6 times completely. All right, that's what it means, the trick means. So now I give you a bigger number. Yeah. For example, 1, 2, 3, 4, 5. Yeah. How do we know? Yeah, this is a large number, very large number. How do we know if this number is divisible by 3?
Yes.
What do we have? Yeah. Yes, it's divisible by 3. How do we know?
5.
We
5
we
plus
add
3.
them together. Yeah, we add them together. 1 plus 2 plus 3 plus 4 plus 5. And then we have, this is a 3, 3 plus 3 is a 6, 6 plus 4 is 10, 10 plus 5 is 15, because the sum is divisible by 3. So this number is divisible by 3. So that's what this trick about. Yeah, there's a quick way, faster way to help you determine if a number divisible by 3 or not. All right? Yeah. So that's that. And let me keep typing, give you the next one. And the same rule apply to 9, okay? If the sum of all digits, of a number, sorry, typo, digits of a number is divisible by 9, then the number is divisible by 9. You can give it a try, okay? For example, 18. 18, 1 plus 8 is 9. 9 is divisible by 9, so 18 is divisible by 9. Okay, and number 4. When a number is divisible by 9, means it has 2 threes as factors. Yeah. And number 4, how do we know if a number is divisible by 5? If the last digit of a number is 5 or 0, then the number is divisible by 5. All the time. Yeah, when you look at the last digit, it is a 5 or 0, then the number is definitely divisible by 5. And last one, if the last digit of a number is a 0, then the number is divisible by 10. Okay, that means if the last digit of a number is a 0, then the number is divisible by 2 and 5. It has 2 as a factor and 5 as a factor. Okay, yeah, I want you to have those, how do you call that? Conclusions. Yeah, I want you to have those conclusions on your note, because we're going to use them on Monday. So far, let me look at Pearson, I hope the issue can be resolved faster. Let me go to my Pearson. Because this is the first week, right? I'm going to tell you what homework you need to do, you need to work on, if you can register. Foundation 2, this one. Our assignments. Today is 14. The end of this week. Oh, okay. So the orientation, right? Inter assignment. You can start chapter 1. You can start chapter 1. You, of course, you will not know all the problems. Yeah, for example, this one, 1.6 is distributed property. Yeah, you can watch the video and practice a little bit. And number 1.7 is combining like terms. We cover that. Section 1.8, evaluate expression. We also covered that. Point 1.9, grouping symbols. So far, we only did parentheses. Later, when we see more complicated expression, we are going to learn other grouping symbols. Yeah, parentheses is the most common used grouping symbol. Other grouping symbols include bracket, braces, absolute value, or even a fraction bar. Yeah, when we see them, I'll show you, okay? Let me see what question you
just
want.
reading the messages from some people, can I just say one thing about the Barnes & Noble?
Yeah.
So I got my email the day of class, but it doesn't just tell you that the code is going to be there. It actually kind of looks like a spam email. So I actually deleted it until I saw today about the Barnes & Noble and went back. But you have to scroll until the very, very bottom to get the access code. It's not up top. You have to keep scrolling through the entire email, and it's at the bottom. And then I just copied it and I clicked the link and typed, you have to click create an account, and I did it with my TCC email, and then you have to go back to your TCC email to verify it or nothing will be accessible. So once you get that code that's at the bottom of the email, and the email is super, super long, so you have to scroll all the way to the bottom and copy it and then register an account on Pearson and then go verify your TCC email before you'll have access to everything.
Yeah.
And then once you go back to that website, though, if you go to Pearson, nothing will be there. It will say that you're not enrolled in any courses. You have to go through Blackboard and click My Lab Math, and then everything will be there. If you click the link or go to the Pearson website afterwards, nothing will be there. You'll have to click My Lab Math or you won't have access to anything.
Yeah, I would like you guys to share your experience with Pearson right here. I have this issue hub, and I would actually, if I were you, I would wait for the lady reset the course materials. Or if you want to get to the homework earlier, then you can look for the emails. It is kind of confusing. Okay, guys, that will be today. Do you guys have any questions? Okay, then we're good today. I'll see you on Monday, guys. Have a good night.
Thank
I
you.
was wondering if we could work ahead on our assignments
Yeah, sure. Of
Okay.
course. Yeah.
I wasn't sure. And what do I do about the first one that says past due? Because I wasn't here.
I'm going to reopen it now.
Okay.
Yeah, I'm going to open it right now.
Yeah, I didn't know class started already because I have multiple different classes starting different months. So
Don't worry about that. I'm gonna reset everything to the last day. Remember we voted on that?
It's okay. You're not alone. I thought class started yesterday, so I was sitting in the classroom for 20 minutes waiting for everybody to show up when class was actually on Monday. So you're not alone.
yeah, I didn't even know it started until like 10 o'clock last night when I checked my email.
Okay, the first assignment, the orientation, should be open now. Let me double check our assignments. Assignment manager.
Yep. It is.
Yeah, now is May 12th. So if you wanna work on the intro, let me see what do we have here. Probably just the orientation, like how do you use the tools, something like that. Yeah, orientation.
So is that video lesson just the next thing due? That's the way I read it.
They all due the last day, but the
No, the
syllabus
video.
has, yeah, the syllabus,
Sorry.
the video. Okay, last Monday. I'm sorry, last class. Yeah, let
Go
me
ahead.
show you how.
Yeah, I'll talk to you later. Go ahead.
No, so this is the Blackboard shell. Do you
Yeah.
see the virtual classroom? Click virtual classroom, and then you'll see a sandwich here, right? Click the sandwich, and you see my name here, probably your name in your Blackboard, and the sessions, and then recordings. Click recordings. Yeah, the
Oh, I
first
see.
one is the one from Monday, and later it takes sometimes 1 hour, sometimes even 1 day. Yeah, give it a little bit of time to upload, and later you'll see 2 recordings, Monday and today.
Okay.
All right.
Okay.
All right, guys. I'll say good night now. I'm sorry.
Okay.
Do you have any questions?
I was going to ask, so that 74 charge,
So
do you think the school can help me get that back, or do I have to get a hold of Pearson?
I think you should call the Pearson customer service. How about you email me?
Oh, dang.
And I could forward your email to the Pearson representative, and that probably would help for you to get a refund. Yeah.
All right. I already did. I sent it to you. Yeah, a couple days ago. So you should have it.
Yeah, you should get the
Explained it.
money back. Yeah, you should get the money back.
Okay. Yeah.
Does
I sent
Amanda
it to you
have
in an
any
email
questions?
saying that it happened, but I'll send it back to you
Oh,
again.
okay. All right, guys. I'll
All
say
right.
good night and
So
see you on
do
Monday.
Monday.
I'm sorry.
Okay.
What is
Good night.
it? I'm sorry.
Sorry,
What
I know
is
you got to
it?
go. Sorry, bye. I was just say the assignment due Monday is just the video lessons we have to do. Is that what it showed there?
Oh, you are asking about the due date of the assignments? This is the
Yeah,
due
the
date
next
of
assignment's
assignment.
due. I didn't know. Go back and do it.
She's
How
given us
about
till May 12th for everything to be done. But if you use the syllabus, it will break down like your what she recommends having done.
here? Go to syllabus and all the way down. Look at here. Yeah, I have the recommended due date.
Yeah,
Yeah, you can
yeah.
start.
I seen all that. I was just saying when you go. Yeah, I've got that done. The MLM. I started a video last night. One of the first video. I was just
Yeah.
wondering what was due by Monday. I can go look in
Nothing
my
due by
lab.
Monday. Nothing due by Monday.
Yeah, everything's
Oh, I
due
thought
by
the
the end of
I
class,
thought the
by
video. Okay, the
May
videos are all
12th.
due by the 27th.
She's going to reset all that to be due
Yeah,
by May 12th.
this MLM is.
I think.
Yeah. Okay. All right. Sorry.
Important thing is okay. Important things is you know that the first exam is beginning of March, and you should plan.
Yeah.
Let me see. Quiz 1, quiz 2. You should plan to get all the chapter 1 and chapter 2 work done. Probably end of February or beginning of March. Yeah, we don't have many sections.
Yeah.
Yeah, it's by chapters.
Okay.
All right, I
Yeah,
really
I
have
see
to
now
go.
there's nothing really due by this next week. All right, I'll let you go.
Yeah.
All right. Bye.
Okay,
Thank
guys,
you.
have a good night. Yeah, bye-bye.
Good night. Bye.